Hello everyone, welcome back to lesson 2 in our Algebra 2 series, and today we're going to be talking about properties and identities. And eventually you'll get so good at these that you'll just know them. It won't really be a property or an identity to you because it'll just be like common knowledge, like a common fact for you guys. So that'll be pretty cool, pretty fun. So let's get started and just jump right into it. Identities are also quite important. You definitely need to know identities. The properties will just be like at heart. You'll just know them eventually. So let's get started. First off, we have our commutative property. And there are two parts to this. There is the addition part, and then there is the multiplication part. All right, multiplication. And let's scroll down so you guys can see this a bit better. So in the addition part, it's going to look generally something like this. A plus B equals B plus A. And the multiplication part is going to look something like A times B equals B times A. And what this is basically saying is that it doesn't really matter which order the digits come in. So if you have A first or B first, it doesn't really matter. You're going to have the same answer. And to give an example of this, I would give something along the lines of 6 times 5 is the same thing as 5 times 6. Because 6 times 5 is 30, and 5 times 6 is 30. It's going to be the same no matter what. As long as you have parentheses or implied parentheses here, it's going to be fine. So that's the commutative property of addition and multiplication. Next up, we have the associative property. And this one, again, comes in addition and multiplication. So we have addition as well as multiplication. And this is what the addition looks like. It's going to look something like A plus B plus C equals A plus B plus C. And the only thing that's different is that the parentheses are in different places. Now, for multiplication, it's going to look like this. All right, B times C. So that's what the multiplication part looks like. And as you guys can see, in both cases, they have different places for the parentheses. So in the first part, the parentheses are around A and B. And the second part, it's around B and C. And really all it's just saying is that it doesn't really matter where the parentheses are located as long as the order is A, B, C, and A, B, C both times. All right, so let me give you an example of this. Say we have 3 plus 5 plus 2 equals 3 plus 5 plus 2, like that. So we can solve that out, and it would be 3 plus 5 is 8 plus 2 is 10. Equals 5 plus 2 is 7, 7 plus 3 is 10. So as you can see in parentheses, you always want to do the parentheses part first, but even so, they were in the same order, so it was still fine and I still got the same answer. All right, and then in multiplication, it's the same concept. All right, so that is the associative property. And now we're going to go on to some identities. All right, so our first identity is going to be the additive identity. Additive identity. And in this one, you're going to want to add a number to the original number that you had. So you're going to add number to get itself. So what I'm saying here is, for example, say if your number was 4, all right, and you want your final number that you end up with to be 4. So you have to add a number in between here that will still give you 4, and that, of course, is going to be 0. All right, 0 is the only number that you can add to another number, and you can still get that latter number as the answer. All right, so in this case, whenever you're dealing with the additive identity, you're just going to add 0. All right, that's the additive identity. And now if we're going to go to the multiplicative identity, it's kind of the same, but not really. All right, so in the multiplicative identity, you're going to want to multiply a number. All right, so you're going to multiply a number to get itself. So then ask yourself, what number can you add to another number to get that latter number as the answer? So say we have 5, right? And we want to multiply it by some number, and we want our final number to be 5. Well, everyone would just basically know that that is indeed 1. 1 is the only number that you can use in this sort of situation. But if you're not convinced, let's solve this algebraically. So say we have 5n equals 5. 5 times a number equals 5. If you divide by 5 and to try and get the n by itself, and again, I'm going to go over this in the next lesson over solving equations, if you divide by 5 on both sides, you get n equals 1. So that's proof enough, right? We solved it algebraically, and we got that our answer was 1. So in multiplicative identity, you're going to use 1. All right? Now we're going to go on to inverses. Very fun. So in inverses, it's going to look like this. It's going to have additive and multiplicative like we had before with additive identity and multiplicative identity. But instead of writing them out, I'm just going to do plus and subtraction sign because I'm lazy. All right, so in additive inverse, you want to add to get 0. So what do I mean by that? Well, let's give an example here. So for example, say we have 3 over 4, and you want to add a number so that you can get 0 on the right-hand side. All right, so what number can you add to 3 over 4 to get 0? Well, it's quite obvious, actually. You're just going to add by the negative of that number, right? Because then it would cancel out. So then you would get the negative of that number, right? So if you wanted to solve this algebraically, you could do 3 over 4 plus x equals 0, and then minus 3 over 4 on both sides, and then you would get x equals negative 3 over 4. So it really works. So that's basically what the additive inverse is. And then for the multiplicative inverse, you're going to want to multiply by a number so that your final answer, is 1. All right, so say for example I had 9 over 7. I want my final answer to be 1. So I have to add or multiply by some number, but we don't know it. And we're going to solve this algebraically because hopefully that'll make it a little bit more clear to see. So in order to get this 9 over 7 to leave and to go on the right-hand side and leave this n by itself, we're going to have to multiply by 7 over 9, right? Because that's the only way that it'll cancel out. So if we multiply by 7 over 9, this 7 cancels out, and then these 9s cancel out. So we're left with, also we have to do it on this side as well. So then we're left with n equals 7 over 9. So as you can see, we originally started out with 9 over 7, and then we ended up with 7 over 9. So do you guys see a pattern here? Well, it's true. When you're going to want to do the multiplicative inverse, you're going to multiply it by the inverse of that original number. So say if you had 5, you're going to multiply it by its inverse, so 1 over 5, and then you're going to get 1, right? Because then these 5s cancel. 1 over 1 is 1. All right? So that's what the multiplicative inverse. And also remember to, in this one, you're going to want to keep the same sign. So what I mean by that is whenever you're looking for an answer, just keep the same sign as you had before, all right? So let me write that down. Keep same sign. All right? And now, finally, we're almost done, guys. Finally, we have our distributive property. So we kind of jumped around there, but distributive property is extremely important, and I think that's why I saved it for last, because this is so algebra. Like, it's so much algebra that it's amazing. Like, all right, this is like what you are going to use all the time in algebra, okay? So that's why I saved it for last, because it's extremely, extremely important. And in the distributive property, we're going to have an example like A times B plus C equals AB plus AC. And you might be looking at that like, what the heck is that? And I'll show you guys, all right? So basically what happened here is you multiplied the A to all components in this parentheses. So you multiplied the A to the B, and you multiplied the A to the C to end up getting AB equals AC. And I'll give you an actual example with numbers right here. So say, for example, we have 3 times 5x plus 7. All right, and now we have to distribute, say the thing says, or the problem says, distribute the coefficient. And so basically what that means is use the distributive property. Fantastic. So we're going to use the distributive property that we just learned, and we're going to have this 3 multiply by all of the things inside this parentheses. So that means we're going to have 3 times 5x, all right, because that's the first portion, plus 3 times 7. All right, and then so we end up getting 15x plus 21. And that is our answer. All right, so that's basically all the properties that you guys need to know for Algebra 2. I hope you all enjoyed, and stay tuned for Lesson 3, because in Lesson 3, we are going to be going over solving simple equations in Algebra 2. So I hope you all enjoyed, and I hope you understood this, and let me know if you guys have any other video ideas, and I'll see you all in the next video. Bye, everyone.